management and research biologist. And today I'll be speaking about the Coghill River Weir Adult Sockeye Salmon Project. The Coghill River Weir is a project we've operated out of the office since 1961. I'll start with a bit of background about Coghill Lake and then how we achieve our objectives of salmon enumeration and biological sampling, and then how that data is applied to research and management. Coghill Lake is located in western Prince William Sound, and the river flows directly into College Fjord. The lake is surrounded by an abundance of glaciers and ice fields. This first figure shows the bathymetry and approximate size of Coghill Lake. Its mean depth is about 46 meters, and it's roughly 2¼ miles from end to end. Coghill Lake is not your typical salmon lake, however. There's a permanent layer of salt water at approximately a 30-meter depth that extends to the bottom. This equates to roughly 45% of the total lake volume. It's meromictic, so these layers do not turn over or mix at all. And this stagnant layer traps nutrients, and it prevents nutrient cycling into the trophogenic zone. Coghill Lake is relatively cold with a short growing season and very high precipitation. The average water retention in the lake is less than 1 year. Both the river and the lake have a high glacial influence and are very turbid. This leads to low light penetration and low primary productivity. The glacial turbidity shapes the zooplankton species and abundance and diversity in the lake. Cladocerians are the preferred food for sockeye salmon because they're large and easy to capture. However, they make up less than 1% of the total zooplankton in Coghill Lake. The majority of the zooplankton in Coghill Lake is copepods, and this large abundance of copepods leads to lower fry growth and lower survival compared to other sockeye lakes in Alaska. From 1993 to 1996, Fish and Game, in cooperation with the Forest Service, performed lake fertilization. 50,000 gallons of liquid fertilizer was applied with the goal of increasing zooplankton abundance and smolt size and survival. This was successful in other lakes in Prince William Sound, however, it was not effective in Coghill Lake. Nutrient enrichment is most effective when large filter-feeding zooplankton such as Daphnia are abundant. Coghill Lake cannot support large abundances of Daphnia because of the glacial turbidity, and further enrichment was not recommended for Coghill Lake, and there was no increase in smolt size seen. We continue to perform zooplankton sampling each year at the lake. This graph shows the abundance of cyclops in number per square meter since 2002. And 2019 is the highest abundance of zooplankton we've seen since we've been zooplankton sampling in Coghill Lake. And then these were the other less abundant species we spoke of, the Bosmina and the Daphnia. And this graph shows their continued limited abundance, although a slight increase in 2019. Despite the limited primary productivity of Coghill Lake, it can produce the largest wild stock of sockeye salmon in Prince William Sound. This image here shows the counts of sockeye throughout the Sound from 1963 to 2011 from aerial survey data adjusted for observer efficiency. Due to the large wild population in Coghill Lake, monitoring the run is a priority for Fish and Game to ensure adequate escapement in a mixed stock fishery. With the Coghill Weir project, we have two main objectives. The first is to enumerate passage, and the second is to estimate age, sex, and length of each age class. A variety of methods have been used to reach these objectives. First, a counting tower and partial weir was used from 1961 to 1974. Following that, a picket weir was implemented. And these photos show some of the early versions of the picket weirs in Coghill River. First, it was the wood picket weir, as you can see. This is an aerial view of a more modern weir. And this is the more modern picket weir without the pickets installed. These are the tripods that support the pickets. The pickets acts as a fence across the river, and salmon can only move upstream where pickets are removed and observers count passage. Here the techs are putting the pickets in, and then it eventually has pickets fully crossed, as you can see in this image. Because Coghill River rapidly changed water levels, picket weirs often wash out. This results in both lost days of counts as well as equipment. Coghill Weir has washed out several times in the last 10 years, with total washouts occurring in both 2009 and 2018. This is some of the 2009 washout. This graph shows the interpolated daily counts from 2018 in response to the washout. The blue days were actually counted, and the red X's are days that were interpolated using a linear regression. The loss of counts leads to uncertainty in escapement information and limited information available for fisheries management. To better achieve the objective of salmon enumeration, and the frequency of washouts led us to implement a floating weir, or resistance board weir, in 2019. Not only can this weir style withstand higher water, there is less equipment loss in extreme water events because it becomes pinned to the bottom of the river rather than washing away. The weir panels are made of PVC and plywood. They measure 3 foot in width by 20 feet in length, and they're anchored to the stream bed using a steel base rail. The panels funnel all of the fish into a chute, and the live trap is attached to the chute on the upstream end. Fish are counted as they travel upstream from the live trap. In this video here, it's not actually of Coghill Weir, but it gives a good visualization of how a resistance board weir is installed and the components of it. How do I get to switch screens often? I won't switch. Oh, there it went. Maybe still not coming. Let's see if I can play it for me.
Heavy jump.
In Coghill, we don't have the luxury of using the boat to transfer all the base rail and panels. Here the base rail is being bolted together underwater. It's in 10-foot sections. The base rail runs perpendicular to the flow, and it's mounted to the bottom using pieces of rebar.
What's the water temp?
What was that?
What's the water temp?
That's a great question. Very cold. It's pretty much done exclusively in dry suits with a couple folks and waiters. video gives a good visual of how the weir actually goes in. But for Coghill Weir specifically, it had a very interesting story of how that weir actually came to Prince William Sound. Rather than constructing new weir panels, the Unalakleet River Weir outside of Nome had extra panels, so we decided to actually bring those to Prince William Sound and bring those to Coghill Weir. This is the site where they were located up the Unalakleet River. It's roughly 30 miles up the river, and they were just stacked in piles there. Luckily, the water was high enough, which actually allowed us to get some more ocean-style boats in to haul those weir panels downstream. And then from the upriver site, we transported them. There were 67 panels, about 10 at a time, utilizing 2 boats. And we transferred those to the small town of Unalakleet. And then from there, we actually put them on giant pallets, and then those panels flew on Everett's air cargo to Anchorage. And then from Anchorage, PWSSC actually picked up the panels, and then they eventually went on the PWSSC landing craft, the Challenger. And here's the visual here of all of those panels loaded up on the Challenger. And PWSSC transferred those panels to the mouth of the river for us. We tried using the crane to unload them. It didn't actually work, but that was the hopes. We ended up hand unloading them. And then from the mouth of the river, we then had to haul them approximately 3 miles up the Coghill River. And this was just using the jet skiff with multiple runs at high tide. Once again, roughly 8 to 10 per load, and it was about 67 panels in total. And then the weir was assembled pretty much as you saw in the video. We've chosen to leave the base rail in for the winter to hopefully ease in the installation in future years, since there's not large ice loads on the Coghill River. This is a few photos of the actual Coghill weir going in. And then here's the weir mostly complete, just finishing up the trap. There's also secondary anchors on the base rail as well, which are the duckbill style anchors, and that's what we're working on in this photo here. And then here's the weir mostly complete. And so in 2019, we began counting on June 19th. This is about a week later than most years. However, given the new weir, we were still pleased with the time frame and felt like we captured the beginning of the run. And so this graph shows the daily passage. Peak passage for Coghill Weir is typically around the 4th of July, and usually passage is pretty much complete by the end of July when the weir is removed. And so the second objective for the weir is sampling age, sex, and length as of the run. The trap serves as the platform for sampling fish, and they're measured for length. Sex is determined by external characteristics, and scales are collected to later analyze age. Here's a few photos of the sampling process along the way. Here they're measuring and collecting scales. Coghill sockeye are predominantly age 1-3, meaning that they've spent 1 year in freshwater, 3 years in saltwater, and they're in their 5th year of life when they return to spawn. This is followed by age 1-2 sockeye. Coghill sockeye rarely spend 2 years in freshwater, and here's an example of the age composition that we saw in 2019. The long-term ASL data set allows us to examine size at age since 1974. This figure shows the decline in size at age for the dominant age class, which was the 1-3, and relative to the steeper decline that we've seen in the Coghill River system. These shifts have been widespread throughout the range of salmon in Alaska and can influence population abundance and fecundity. Having these long-term data sets, such as those that we collect at the Coghill Weir, can offer insight onto these large-scale trends. ASL is not only used to understand run composition, but it's also what's used to create the forecast. And I won't go too much into the forecast, but just kind of as a quick example here, the 2020 forecast, we've got a point estimate of 175,000 fish, which is just slightly below the 10-year average. And by understanding and knowing those age classes, Stormy uses the sibling model basically to determine, knowing historical relationships between age classes, the run forecast for the upcoming year. And so both escapement and ASL data from Coghill Weir are used to determine how the commercial fishery is managed. Timing of the main bay hatchery sockeye fisheries overlaps with the run timing of Coghill and other stocks within the sound. The state of Alaska mixed stock salmon policy states that the conservation of wild salmon stocks consistent with sustained yield shall be accorded the highest priority. Managing Coghill stocks can be especially difficult because their migration corridor passes through several fishing districts. Both otolith data to determine hatchery versus wild origin, as well as weir and escapement counts, are used to determine the fishing time and area. And then here we have a graph of the daily passage relative to the lower and upper bounds of the escapement goal, and then the same graph below for cumulative passage. And here the escapement goal is based on the 10-year average run timing of what minimum and maximum daily passage we need to achieve that escapement goal. And so 2019 counts are shown in blue. And as you can see, when the daily counts fall below the lower end of the escapement goal for too long of a period of time, that's when more conservative management actions would be taken. And the same goes for when that goes above the lower and even above the upper end. That's typically when the fishery will be liberalized. The graph on the bottom shows the same, but that just looks at cumulative counts rather than daily passage. And so this graph here shows the total run, which that includes all of the Coghill wild stocks harvested in the commercial fisheries in other districts, and as well as the total weir count here. There is some limited sport fishing at Coghill weir. It's fairly insignificant due to the remote location, so the majority of fish not needed for escapement are available for commercial harvest. And then this figure here is escapement from 1974 to present. The red bars indicate the years which we have not met the lower bounds of the escapement goal. This also serves to demonstrate that years of over-escapement are often followed by years of poor returns. And this is largely due to the overgrazing of zooplankton. And this really also shows the importance of being able to accurately monitor the Coghill run, both to make in-season management decisions as well as kind of maximize the productivity of the system. And so to conclude, Coghill Lake is typically one of the largest contributors of wild sockeye salmon in Prince William Sound. Fish and Game has monitored this system since 1961 using a variety of methods, and escapement counts and ASL data are critical for in-season fisheries management and forecasting. And with that, I'd like to open it up to questions. Any questions?
Why don't salmon like cold spots?
So they are faster and smaller, and so it's just kind of more bang for their buck to go after the larger and slower moving zooplankton. Yes?
Yes, ma'am. I would like to recognize Dr. Moffett, who sacrificed the best years of his life to research and management of RAE fisheries.
Absolutely.
Please give him a call.
You mentioned that the bottom of the Coghill Lake is salt water. Does it ever change out, or is it just the same water there century after century, or how? What's the scoop on that salt water down there?
So it stays stagnant in the bottom. Some lakes will have, they'll have multiple layers, but as ice comes off, those layers will mix or change, but Coghill Lake, it remains stagnant in the bottom. I'm not sure how that came to form, but it's meromictic, so it doesn't mix and it doesn't typically move.
But it probably doesn't even have any oxygen in it or anything.
Very nutrient poor. Yes?
With that, have you ever done have any cores ever been done to look at, because any scales falling off over time would be preserved in the sediments without oxygen, to look at 100 years ago or 200 years ago with fish coming in.
I'm not aware of Fish and Game doing any of that research. I'm not sure if other agencies have or not, but not that I'm aware of.
Yeah. And I think the saltwater came because that whole area was had glaciers on it, and the whole elevation was lower, so Coghill River would have been all tidal when the glaciers first came off, and then rebound after glacier retreat, then isolated it to where the tide only comes up halfway up the river now. all before it probably came all the way up the river.
That makes sense, thank you.
I have seen some reference to cores taken in the lake, but I've never seen any analysis or anything.
Huh.
I've always thought, man, we gotta do something. I'm super interested. I think everybody that's curious
Yeah,
about it is.
yeah.
I'd love to send an ROV with a bunch of lights down on there. I could just
Scott's
envision
got one.
like
I know where one's at.
200 years worth of sockeye carcasses.
Well,
Well, like, what's that like, you know?
Yeah.
I just wanna know. So.
Coffee cups.
I bet
that's what
people,
you-
people wonder about
Beer
these,
cans.
oxygen, air, little coves, there's a few in the sound where your anchor comes up, smelling rotten eggs. 'Cause
Pretty
it's,
gnarly, yeah.
Those would be great places to do cores, looking at herring scales and things like that.
Sure.
But, Coghill would be with them.
I should also add a plug that we are always looking for technicians. So if anyone knows of anyone, Alaska residents, we are always looking for folks.
Strong.
No fisheries background required. Any other questions? Okay,
What do you
lovely.
guys use to anchor the weir on the bottom? Use railroad rails or what?
So it's 10-foot sections of basically a steel angle iron, and then those have essentially wings bolted to them that run perpendicular to the angle iron, and then the rebar is pounded into those steel wings, and that's how it's anchored to the bottom, and then a cable runs through the eyelets of that, and then the panels have hooks that attach to that cable. And then we have secondary duckbill anchors just in case.
That washout you mentioned, that was just what, like a big rain event, just flooded around.
Yeah, it's been a continual problem with the picket weirs in Coghill River, just, whether it's partial washout and they just pull the pickets to lessen the force and the water goes through, or some years like in 2009 and 2018 it took a lot of the equipment with it.
So with the floating, it's the downstream end is floating,
Correct.
and it's just if you get enough water, it'll press it down and flow over the top of it?
Yep, so there's attached from the plywood boards basically to a midpoint on the panel. There's actually a cable. So you can, it's called setting the boards, and so you can force those boards to about a 45-degree angle, and that will keep them afloat much longer, and that allows you to be able to count in the high water. But then when it reaches a point where it's just too much water, the force just pins it to the bottom rather than sweeping it away.
So with this new system in 2019, we didn't have any weir washouts with floods or whatever.
We didn't see the same water levels that we saw in some of the other years. There's been success with it in other systems in high water, and we're hoping we won't test it anytime soon, but confident that it should be able to withstand much higher water should they come.
It was really, really low water too this year at Coghill.
Right.
Everywhere
with it.
Even moderate flows,
How many pink salmon casts you to weir this year, Gene? That's been a problem in the past with the picket weir. All those pinks go upstream and die, and then they have to throw all the carcasses over the weir. Whereas the floating weir, you can just step on it quickly and lower it a little bit and have the carcasses wash over it.
Correct, yep. This year we saw only about 30,000 pinks over the weir actually, but years with more pinks, it'll certainly be convenient to be able to clear them that way. It's just walking on the weir panels.
What do we know about the funding for counters this year?
At this point for Coghill, as far as we know, we are funded and we are set for Coghill.
And
Yes.
Is it right, all 5 species of salmon utilize the Coghill system?
So there are some limited coho runs. For the most part, though, it's just sockeye and pinks. The weir in some past years was operated later to count coho. With ending the weir at the end of July, we don't really get coho coming through. Every once in a while, just 1 or 2. We don't have chum salmon going past the weir, and just 1 or 2 kings a year.
But there are more chum that spawn below the
Mhm.
lower.
Yeah.
Hmm.